Thank you, Nicola, for your introduction. Hello, everyone, and good morning. My name is Andrea-Ibba, and I'm a PhD researcher at the University of Cagliari in Italy. Today, I will present to you a framework to implement a digital building logbook that from now on I will call DBL. As the title suggests, my focus will be on understand what data can be considered valuable to store in a DBL and how the stakeholder can engage with such data. This work has been done in collaboration with different researchers from different organizations, such universities and companies, as you can see in this slide. Moreover, I want also to thank the European-funded project called Chronicle, which partially funded this research. To begin, I want to focus on the DBL definition from the European Commission, which defines the DBL as a common repository for all relevant building data, which facilitates informed decision-making and information sharing. Moving from the definition to the literature, we observed that there are still some open aspects about the DBL that are not yet clarified. One of these can be represented from the question, what data can be considered relevant or valuable to store in a DBL? One general answer to this question can be data that can add value to the building, thus data that can engage stakeholders to easily upload, access, and use it in real-world scenarios. But from this answer, another question may follow, that is, how can this data be stored to fulfill these needs? Given these challenges, we set the three main objectives of our work. These objectives are first to define a non-exhaustive list of valuable files for DBLs. Second, to study real-world scenarios to understand the stakeholder engagement and the use of valuable data. And the third one is to propose a framework to outline effective data storage and management methods. Beginning with the first point, in the next slide, I will define the steps that we took to define a list of valuable data for the DBL. So we began this analysis by studying the literature on this topic. First, in the DBL literature, we often read about indicators. These indicators define the types of information that is valuable or that can be valuable to store in the DBL. In this table, we construct a table from the findings of a comprehensive service about scientific articles on the DBL. Here, we can observe that we have a comprehensive list of the indicator categories with its role and the possible metrics to define them. But once we construct the table, we don't actually have a list of real-world files to store in the DBL. So in our work, we identified a non-exhaustive list of real-world data files, of important data and files that are produced in different phases of the building life cycle. What we have done was to study for each files how these files can contribute to the indicators presented before. So for example, here we have the baseline IFC files that can contribute to three different indicators categories, while other files, like for example here, the file alarm system reports, can contribute to just one category. Once we created this list and this association, we proceed to study how the stakeholders can engage with such data. First of all, we identified the 5 main stakeholder groups involved and interested in the DBL, that are governmental agencies, construction companies, building owners and users, financial institutions, and utility companies. Once we identified the stakeholder groups, we studied which indicators can be of interest for each stakeholder groups. And then, since we already construct an association between indicators and valuable data, we ultimately construct an association between stakeholder groups and valuable data. Like, for example, here we can observe that for the building owners and users, all the valuable data previously defined in the table can be of interest. Once we construct this association between stakeholders and valuable data, we work to create an high-level framework to effectively store this data. To ground our framework ideas and valuable files, We studied 3 real-world DBL implementation, thanks to the findings of the demo Blog project. These examples showed us the importance of considering each DBL-specific goals, stakeholders, target market, and most valuable files to reach their goals. We can say that it's crucial to design DBLs that are adaptable to different needs and challenges. With our framework, we are not trying to reinvent the wheel. Rather, we are using ideas and processes from other fields, and we want to modify them to suit the specific needs of the building industry and specific for the needs of the DBL. In this slide, we can observe a general overview of our framework with some key aspects of it. First, we intend to create a DBL framework which adopts the perspective of a local, possible multi-building, and with a controlled data flow. Other key points are that our DBL is envisioned as a cloud-based repository that acts as a sink for data. This means that we want our DBL to store all the valuable files in its central repository rather than, for example, fetching the data from other external sources, because these sources often are heterogeneous, so this will add a lot of complexity to our DBL. The last key point is the security, because since we are storing all the data inside the central storage of the DBL, we can ensure that all the files are encrypted, secured, and made available only through the DBL user interface or APIs. Going more into detail, this is the structure of the internal data storage of the DBL in a high-level way, let's say. First of all, we have the building entity with some general information about the building. Then we have a list of entities that we call records. These records, each record has a reference of the main building entity. Then each record can have one or more files associated to it. This structure is built like that mainly to support 3 aspects that we think are keys in our framework. These aspects are the file integrity, the manageable metadata, and the cohesion and scalability. With file integrity, we mean that once the file is uploaded in our DBL, these files should remain unaltered, and for example, this functionality in the next future can be supported by the blockchain. Then we have the manageable metadata, because since our file, the file stored in the DBL, should remain unaltered, we want an entity that can ensure that the DBL can be flexible and customizable to various needs. And this entity is the record entity that I presented before. The third key point is the cohesion and scalability that is supported from the main building entity that connects all the records between them. Here in this slide, we can see an example of our structure implemented. Here on the left, we have the record structure with some general information, like for example, we can consider a general information, the upload date and the uploaded by, while we can have some other information that are specific to the type of file that is related to this record. Like for example, here we have the issue date or expiring date, while on the right we have a preview of the file that is related to this record. To conclude, if we want to summarize our findings in just a few words, we can say that we identified files for a building and assessed their value for a DBL using literature indicators and real-world stakeholder usage. From this, we developed a practical framework for a local DBL. While initially focused on local implementation, this framework is designed to be scalable and interoperable for future expansion. The information coming from this work formed the basis for our ongoing and future work. The first step in our future work is to construct our DBL architecture exploiting the just presented framework. Then we are already implementing such architecture in the context of the European funded project called Chronicle. And once we will finish the implementation and the architecture, we will evaluate the platform using empirical data and standard practices. Lastly, I'm researching and developing a chatbot that interacts with IFC file information that will be integrated in the future in this DBL framework. With this slide, I'm ending my presentation. Thanks for your attention, and I remain available for any question you might have. Again, thank you.